Welcome to Cosmic Whispers, where cosmic mysteries come alive. Your journey beyond the stars begins now. Imagine standing beneath a vast starry sky and realizing that the stars you see might not be the only things out there. What if there were entire galaxies, so massive, so distant, that they could completely change the way we understand the universe? In 1920, an astronomical discovery would do just that, challenging everything we thought we knew about the cosmos, the Andromeda galaxy. Before this momentous discovery, the prevailing belief among scientists was that our Milky Way was the only galaxy in the universe. The idea of other galaxies, vast collections of stars, gas and dust, was simply inconceivable to most. Our place in the cosmos was understood to be centered around our galaxy, the Milky Way. But all of that would change with one groundbreaking observation made by Edwin Hubble using the powerful Hooker telescope at Mount Wilson Observatory in California. But let's rewind a little. How did Andromeda even come to be discovered? And what did it mean for our understanding of the universe? For centuries, astronomers had noticed a fuzzy, cloud-like object in the night sky. This object, which we now call the Andromeda galaxy, had been observed for hundreds of years, but its true nature remained a mystery. In the early days of astronomy, it was often classified as a nebula, a cloud of gas or dust, and astronomers couldn't agree on whether it was part of the Milky Way or something completely separate. To understand why this was such a monumental question, you need to grasp the context of the time. The late 1800s was a period when many astronomers believed that the Milky Way represented the entire universe. Some, like Sir William Herschel, argued that the universe was made up of star clusters within our own galaxy. The idea of other galaxies, entirely separate systems of stars, seemed impossible. If the Milky Way was the whole universe, then everything beyond it must be part of something entirely different, something that humans simply couldn't perceive. Then came the crucial moment that would challenge everything. In the early 20th century, a new generation of astronomers, including Edwin Hubble, began using increasingly powerful telescopes to peer deeper into space. And it was in 1920 that Hubble's work would become the turning point for cosmology. Hubble's observations of Andromeda went beyond simple imaging. Using the Hooker telescope, which at the time was the largest in the world, Hubble identified individual stars within Andromeda. Not only did this provide direct evidence that Andromeda was made up of stars, just like the Milky Way, it also revealed something far more profound. These stars, Hubble realized, were located over 2 million light-years away from Earth. This was far greater than the size of the Milky Way itself, which led Hubble to a bold conclusion. Andromeda wasn't part of our galaxy at all. It was an entirely separate galaxy. To comprehend the significance of this, consider that 1 light-year is roughly 9 trillion kilometers, or 5.5 trillion miles. When you multiply that by 2 million, you start to grasp the immense distance between our galaxy and Andromeda. In the early 20th century, this discovery shattered the long-held belief that our galaxy was the only one in existence. It was the first clear evidence that there were other galaxies beyond our own. But the implications didn't stop there. The revelation that Andromeda was a separate galaxy led astronomers to ask even bigger questions. How many galaxies are out there? Could there be life elsewhere? How did the universe come to be? The concept of the universe as an isolated, static place was beginning to crumble, and with it, our understanding of the cosmos was evolving into something far more complex and awe-inspiring. But this breakthrough didn't come without resistance. Even though Hubble's findings were groundbreaking, many scientists at the time were not ready to accept them. There was a fierce debate over the true nature of Andromeda. Some, like Harlow Shapley, argued that Andromeda could still be part of the Milky Way. Others questioned whether Hubble's distance calculations could even be accurate. After all, how could something so far away be measured with precision? For some, the very idea of other galaxies was too radical to accept. The idea of a vast, infinite universe filled with countless galaxies was a difficult concept to grasp. Yet, Hubble's work was more than just an observation. It was the beginning of a revolution in our understanding of the universe. His work laid the foundation for the modern field of cosmology, and it pushed us toward a new understanding of our place in a much larger, ever-expanding cosmos. This discovery of Andromeda and its true nature would ultimately set the stage for another key breakthrough in cosmology, the realization that the universe was expanding. But for now, let's pause here, because the discovery of Andromeda and the fierce debates that followed set the stage for a far larger revelation, one that would change our view of the entire universe. So, what did the discovery of Andromeda really mean for humanity? It meant that we weren't alone in the universe. It meant that there were other galaxies out there, possibly other civilizations. And perhaps most dramatically, it meant that the universe was far bigger, more dynamic and more mysterious than we could have ever imagined. Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free and it helps us grow this community together. Now that we've explored the origins of Andromeda's discovery, let's dive into the intense debates that followed, the scientific drama that shaped our understanding of galaxies and the universe. The year is 1920, and the scientific community is on the edge of a revolution. Edwin Hubble's discovery of the Andromeda galaxy has shaken the foundations of everything we thought we knew about the cosmos. But despite the clear evidence Hubble presented, not everyone was ready to accept this new reality. In fact, the discovery sparked one of the most intense debates in the history of astronomy, a debate that would take years to settle and would eventually change the way we understand the universe. Hubble had done the seemingly impossible. Using the Hooker telescope, the largest in the world at the time, he had carefully observed the stars within the Andromeda nebula, proving that it was not a cloud of gas and dust as many had believed. Instead, it was an entire galaxy, a massive collection of stars, just like our own Milky Way. And to top it off, he had calculated its distance to be over 2 million light-years away. At first glance, this seemed like irrefutable evidence that Andromeda was a galaxy far beyond our own. Yet many scientists were not convinced. The problem was that Hubble's discovery ran headlong into a long-standing belief that had dominated astronomy for centuries. The idea that there could be other galaxies outside the Milky Way was unthinkable. After all, if Andromeda was its own galaxy, that would mean that the universe was far more expansive than anyone had imagined. It would mean that our Milky Way wasn't the center of everything, and that, for many astronomers, was a tough pill to swallow. The debate became particularly heated with Harlow Shapley, a prominent astronomer of the time, who was one of Hubble's fiercest critics. Shapley had his own theory about the nature of the universe. He believed that our Milky Way was far larger than most people thought, and that Andromeda was simply part of it, just another nebula inside our galaxy. For Shapley, Hubble's claims weren't just wrong, they were a challenge to his entire worldview. Shapley argued that Andromeda's size, which was still a mystery at the time, could be explained if it were part of the Milky Way. After all, if Andromeda was really 2 million light-years away, it would be enormous, much larger than the Milky Way. This in turn would mean that the Milky Way was far smaller than most astronomers believed. Shapley, holding fast to his own ideas, could not bring himself to accept the notion of a larger universe. The debate between Hubble and Shapley became something of a battle for the future of astronomy. It was a clash of paradigms, a confrontation between the old view of a small, contained universe and the new vision of a vast, infinite cosmos. Hubble's findings suggested that the universe was much larger and more dynamic than anyone had imagined, while Shapley clung to the traditional view that the Milky Way was the dominant structure in the universe. For years, the two astronomers debated fiercely. They presented opposing arguments in public lectures, wrote about their theories in scientific journals, and even held personal discussions that became legendary in the field. But it wasn't until later, in the 1920s and 1930s, that the evidence began to tip the scales in Hubble's favor. The key turning point came in the form of more precise measurements. Over time, astronomers were able to refine the techniques for measuring the distances to far-off galaxies. The discovery of Cepheid variable stars, stars that pulse at regular intervals, allowing astronomers to calculate their distance, became crucial, And in the early 1930s, another astronomer, Milton Humason, worked alongside Hubble to improve their distance calculations. Using these more accurate measurements, they confirmed that Andromeda was indeed over 2 million light-years away, a staggering distance that proved it could not possibly be part of the Milky Way. This new evidence forced Shapley and others to reconsider their views. Slowly but surely, the idea that Andromeda was a separate galaxy took hold, forever changing our understanding of the universe. But the story didn't end there. In fact, the debate had laid the groundwork for a much larger realization that would come just a few years later. Hubble's discovery of Andromeda was just the beginning of a wave of cosmic revelations. It would lead directly to the discovery of other galaxies, the realization that the universe was expanding, and the eventual birth of modern cosmology. It's fascinating to think about how this intense scientific battle, filled with passion and frustration, ultimately shaped the course of human knowledge. The debates between Hubble and Shapley weren't just about who was right. They were about how we as humans relate to the universe itself. The idea that we are part of an unimaginably vast and ever-expanding cosmos was hard to accept at first. But over time, that new worldview became undeniable, and our understanding of the universe would never be the same again. And that brings us to a crucial point in our story. The discovery of Andromeda didn't just challenge our sense of scale. It also invited scientists to think about the bigger picture. If there were galaxies beyond the Milky Way, then how many were there? How far did the universe extend? And what did this mean for the beginning of everything? These questions would soon lead to the discovery of something even more profound. Before we explore the next chapter, let's pause for a moment to reflect. Think about the debate that raged for years over something so fundamental. What does it say about the nature of scientific discovery and the persistence of truth when two brilliant minds armed with different beliefs and theories face off in a battle for understanding? What is the value of challenging established norms, and how can a single discovery, like that of Andromeda, change the course of human history? In the wake of Edwin Hubble's discovery of the Andromeda galaxy, the world of cosmology was in turmoil. What had seemed like a singular, static universe now appeared to be a dynamic, ever-expanding cosmos, far larger, more mysterious, and more complex than anyone could have imagined. But Hubble's discovery of Andromeda did more than just prove the existence of other galaxies. It set in motion a chain of events that would forever alter our understanding of the universe, leading to one of the most profound and mind-bending discoveries in science, the expansion of the universe. But before we dive into the mechanics of cosmic expansion, we need to take a step back and appreciate the significance of Hubble's work. While his discovery of Andromeda was monumental, it wasn't just the revelation of other galaxies that was important. It was the way in which it fit into a much larger, more intricate puzzle of cosmic evolution. Hubble had opened the door to a new way of thinking about the universe. By establishing that Andromeda was a separate galaxy, he challenged the idea that the Milky Way was the center of the cosmos. This wasn't just a shift in scale, it was a shift in perspective. The universe was not just a collection of stars, but a vast expanse filled with galaxies, each with its own stars, planets, and possibly life. Suddenly, humanity's place in the cosmos was far less certain. We were no longer the center of it. Oh, but this realization was only the beginning. The true revolution began when Hubble turned his attention to the broader picture of the universe itself. By observing galaxies in different directions, he began to notice something extraordinary. Galaxies appeared to be moving away from us. This was more than just a casual observation. It was a fundamental clue that would lead to one of the most important discoveries in modern science. The universe was expanding. Hubble's discovery that galaxies were receding from Earth, known today as Hubble's law, was a pivotal moment in cosmology. By measuring the redshift of light from distant galaxies, Hubble found that the further away a galaxy was, the faster it appeared to be moving away from us. This phenomenon was best explained by the theory that the fabric of space itself was stretching, causing galaxies to move apart. In other words, the universe wasn't static, it was in motion, and it had been expanding ever since the moment of the Big Bang. At the time, This was a revolutionary idea. For centuries, scientists had believed that the universe was either static or cyclical with no real beginning or end. But Hubble's discovery fundamentally changed that view. The idea of an expanding universe suggested that everything in existence had originated from a single point, an event now known as the Big Bang. The implications of this were staggering. If the universe was expanding, it meant that at some point, in the past, everything was much closer together. In fact, the further we traced back in time, the smaller and denser the universe would have been until it was concentrated in an infinitely small, infinitely hot point. This point, the singularity, marked the beginning of everything: space, time, matter, and energy. This realization was both awe-inspiring and humbling. The universe we observe today is the result of a vast expansion that began billions of years ago, and it's still expanding today. But how did Hubble's discovery lead to the theory of the Big Bang? The key was the connection between the expanding universe and the cosmic background radiation. In the 1960s, scientists Arno Penzias and Robert Wilson discovered a faint, uniform radiation coming from all directions in space. This cosmic microwave background radiation was a relic from the early universe, an echo of the heat left behind by the Big Bang. Its discovery provided the final piece of the puzzle, confirming that the universe had indeed begun with a massive, hot explosion that created all the matter and energy in the cosmos. With this evidence in hand, scientists could now propose a comprehensive model of the universe's origins, one that explained its expansion and its eventual cooling. The Big Bang theory became the dominant explanation for the creation of the universe, replacing older, static models. And yet, despite the overwhelming evidence, it took time for the scientific community to fully embrace the idea that the universe had a beginning, a finite past, and a future. What was particularly remarkable about Hubble's role in this discovery is that it wasn't just his observations of Andromeda that led to these revelations. It was his method of observation. Hubble's approach to cosmology was revolutionary because he didn't simply focus on the stars and galaxies within our immediate vicinity. He looked outward, into the deep, distant reaches of space, and by measuring the light from these far-off galaxies, he could trace the history of the universe itself. Imagine the vastness of it all, the mind-boggling distances that separate us from the galaxies that Hubble studied. To think that the light from those galaxies had traveled billions of years just to reach his telescope, and that this light held the key to understanding the very nature of reality itself. It's as if, through the lens of a telescope, we could look into the past and glimpse the very moment the universe began. But Hubble's contributions didn't end there. In addition to revealing the expanding universe, he also helped establish a critical framework for understanding the age and scale of the cosmos. Using his law of redshift and his observations of distant galaxies, Hubble helped estimate the rate of expansion of the universe. This would go on to play a crucial role in determining the age of the universe itself, currently estimated at approximately 13.8 billion years. The universe, once thought to be eternal and unchanging, was now understood to be a dynamic, evolving entity. The discovery of Andromeda was the key that unlocked a deeper understanding of the universe's vastness, and the realization that everything we see today is the result of a cosmic explosion that happened billions of years ago. The universe was no longer just a collection of stars and galaxies. It was a living, breathing entity, constantly expanding and evolving. As we continue to explore the cosmos, we are constantly reminded of how much we still have to learn. The discovery of Andromeda, the identification of the expanding universe, and the eventual development of the Big Bang theory are just the beginning of our journey. Today, astronomers continue to observe distant galaxies, black holes, and cosmic phenomena that challenge our understanding of the universe. And yet, even as we reach further and deeper into space, the most profound question remains: what is the ultimate fate of the universe? Will it continue expanding forever, or will it eventually collapse back in on itself? Will we ever reach the farthest galaxies? What mysteries are yet to be uncovered in the depths of space? The answers to these questions lie beyond the edge of the observable universe, waiting for the next generation of astronomers, like Hubble before them, to push the boundaries of what we know. But for now, we can only wonder, what discoveries lie ahead in our quest to understand the true nature of the cosmos? As we stand on the shoulders of giants, looking back on the incredible discoveries of the past century, the Andromeda Galaxy remains one of the most powerful symbols of humanity's ever-expanding understanding of the universe. What began as a contentious debate between two brilliant minds, Hubble and Shapley, has blossomed into a cornerstone of modern cosmology. But the legacy of Andromeda isn't just about its discovery. It's about what that discovery has allowed us to see and understand about our place in the cosmos. Today we know that Andromeda is more than just the closest spiral galaxy to our own. It's a window into the vast and complex web of galaxies that makes up the universe. It serves as a living testament to the dynamic, interconnected nature of the cosmos. And while it might be a little over 2 million light-years away, Andromeda is still very much part of our cosmic neighborhood. But there's something else that Andromeda teaches us. Even the most familiar parts of the universe, places that seem close and known, hold mysteries that can completely reshape our understanding of everything. Take, for example, the ongoing research into the fate of Andromeda and the Milky Way. For decades, astronomers have known that our two galaxies are on a collision course. In about 4 billion years, the Milky Way and Andromeda will collide, merging into a single massive elliptical galaxy. This cataclysmic event will likely reshape the stars and planets within both galaxies, but it will also offer scientists a once-in-a-lifetime opportunity to study galactic mergers in real time. It's a reminder that the universe is constantly in flux and that nothing is permanent. The cosmos, like everything in life, is always evolving, but the story doesn't stop with the Milky Way and Andromeda. Thanks to the discovery of Andromeda as a separate galaxy, we've gone on to identify over 2 trillion galaxies in the observable universe, each with its own unique structure, history, and mysteries. Andromeda was the first stepping stone that proved the existence of these far-off cosmic islands, and it has played a crucial role in shaping our understanding of galactic evolution, dark matter, and even the mysterious forces driving the expansion of the universe itself. Today, as we send more sophisticated telescopes like the James Webb Space Telescope, JWST, into space, we are able to peer deeper into the cosmos than ever before. With each new discovery, we are uncovering new details about the Andromeda Galaxy, its stars, its black hole, its interactions with the surrounding cosmic environment. Even in the 21st century, Andromeda remains an object of intense study, a treasure trove of scientific insights waiting to be unlocked. But perhaps the most profound legacy of Andromeda lies in the way it has shaped our philosophical and existential outlook on the universe. Before Hubble's discovery, humanity lived under the illusion that we were the center of the universe. We gazed at the stars and imagined that everything revolved around us. But the realization that Andromeda was a separate galaxy, and that the universe was filled with billions, if not trillions, of other galaxies, dissolved that illusion forever. We were no longer the center of the cosmos. We were just one small part of a vast, expanding universe. And in that realization, humanity faced a powerful question. What is our place in all of this? Andromeda has, in many ways, been the catalyst for that very question. Our perspective on the universe, on the nature of life, and on the meaning of existence has changed dramatically since the discovery of Andromeda. As we look out at the stars, we are reminded that the universe is a place of infinite possibilities and unknowns, and as we continue to push the boundaries of space exploration, we are also confronted with the idea that we are just one small piece of an unimaginable larger whole. In a way, the discovery of Andromeda reminds us of our humility as a species. It's easy to get caught up in the day-to-day struggles of life, personal ambitions, conflicts, and trivial matters. But when we look up at the stars, we're reminded that we are part of something much larger than ourselves. The universe stretches out in all directions, beyond what our eyes can see, and yet we have the privilege of exploring it. Every new discovery, from Andromeda to the furthest reaches of space, brings us closer to understanding the true nature of the cosmos. But at the same time, it also shows us how much more there is to learn. Andromeda is a reminder that the journey of discovery is never truly over. In fact, it's only just begun. As we close this chapter on Andromeda, we are left with one final thought. What is the next great discovery waiting to be made? What galaxy, what distant star, or what phenomenon will rewrite everything we think we know? The universe is vast and full of surprises, and we are just scratching the surface of what lies beyond our reach. So, as we continue to explore the cosmos, let's remember that the story of Andromeda is not just a chapter in the past. It's a part of an ongoing narrative, one that continues to unfold every day. And as long as we remain curious, and as long as we continue to look up at the stars, there will always be new questions to ask and new discoveries to make. If you enjoyed this exploration of Andromeda, the universe, and the history of our cosmic journey, don't forget to like this video and share it with your fellow explorers. Let us know your thoughts in the comments below. What's the next big cosmic mystery you think we'll uncover? We'd love to hear from you. The mysteries of the universe are far from solved, and we've only just begun to scratch the surface. Until next time, keep your eyes on the stars and never stop asking the big questions.